Welcome to this short tutorial produced by CertaSIM LLC. We will cover how to post-process an IMPETUS simulation using the post mode in the IMPETUS AFEA solver GUI. Here we have the result files from IMPETUS run. We have the binary files here, .imp files. We have the main file here where we have the child files here, and these files will be read in when we're reading in the main file. We also have the .out file, which are the ASCII files that are typically much more frequently outputted. So they have around 1,000 typical 1,000 points, where in the database here, the binary database, we will typically have around 100 states or 100 points. We can open the impetus.imp file in different ways. We can double click on it. We can drag it over to the icon. We can also open the IMPETUS solver here, and we can just go to solve, for example, select the job that we want to post-process, and then simply hit the post-processing button. Then this is the post-processing interface. We have the different modes over here. We have the object tree here. We have a graphic interface here. This is our graphic area where we have the model. You can see this model here as a blast model. We have the soil. In here we have a high explosive, and we have a target here. This is our model information. We can list different things. We can also expand if we want to show more things. We have our top menu here. Home, select, blank, contour plot, and view and tools. We can, of course, do different things under files. We can reload. We can restore the default settings, but we can also export the mesh, for example, if we're interested in doing that. We can zoom in if we're using the wheel on the mouse. We can zoom in and out. We can rotate by holding down the left mouse button. And we can also zoom in with the right mouse button here. The right mouse button is also used to go away from, or escape, I should say, from different menus if we get into it. For example, if we click on this one, you can see in the object, when I click something, it comes down here, information. Let's say, for example, we go in and take it, there's a material in here. All that is listed here for easy post-processing, so we know what we have in the model. Here's a geometry. But then I can go away from this by clicking on the right button from the mouse, and I can collapse these, and I can expand, and I can look at all these things. Here we can see that we have an orientation cube, that's what we call it. I can just simply click on this, and it's very easy. Then it changes into it's oriented after what we want to have. It's a very simple way of doing it. I can also, under home here, I can zoom in, zoom to scene, zoom to object, zoom in and out. I can do a rubber band if I just want to see this one. Here, the structure here, and I can turn off my particles. We have another tutorial that talks more about how to post-process blast results. But let's just turn it off. Now we are looking at the structure. You can see here there's been used symmetry in this. I can change if I want to see the mesh. I don't want to have the mesh lines, perhaps. There's different ways of seeing the object. Now we go out a little bit. Down here is where I can animate. You see a very large deformation. Go over here. It's actually tipping over here. One thing that's interesting is these are cubic elements. So that means that you can see the geometry, how these elements are actually curved. So this is one element. You can see here, this is one element. So the solid lines here, the black lines here are defining the elements. And we have the internal nodes here. There's 64 integration points and 64 nodes in these high order element. But look at that curvature. This is one element. And this is because we're using these smooth lines here. If I went into configure, I can actually show you. You can configure the different appearance and blast and how the SPH, the gamma SPH should look like. But you can go in here and we can say, okay, this is piecewise linear element visualization. you can see now that one element is showing like these lines here, which would be typical in legacy codes, right? Then we will have one element here, but we actually have higher order elements here. So we'll do it like this. And this is also using context. So this is pretty important that we have that kind of accurate geometry, especially for certain applications. And down here, you can see the global coordinate system. If you go up here, you can see in this menu up here, we also can set an orientation point. So for the visual now, I can rotate it according to this rotation point. I can also flip it like this. And we can change it to a parallel mode compared to a perspective mode, how the projection is. And again, zooming in and out with the wheel is very convenient. We can identify parts, we can show and we can hide. We can, of course, measure distances. We can go and explore the folder where we have our model in. We can view our output file, the info file. We can view an attention file. I can go to ASCII plot, which means that I will make a history plot from one of our database. For example, I can go in and do a p-blast contact. That it will be the contact from the discrete particles. On this part here, you can see this is, then a plot window comes up. I just took the impulse in the C direction. And then under this plot here, and of course I can do it to the whole screen. I have zoom in, I can change how everything is looking like. So this is just a plotting interface. I can do scaling. I can actually look at a table. It comes up and show me what it is, the max and mean, very convenient when you're comparing runs. I can integrate, I can add, I can do a lot of things in here. I can put text on and so forth. If you go, and of course I can save and I can take pictures there as well, or make plot files. So if I've been away from now, I had clicked away from it, but I can go back to my plot window just by the plot. So all the files that can be plotted in this one here will be the .out file. They can be plotted here in the ASCII plot. I can create an image. There's different options here. I can render with the logo, without the logo, transparency I like. And then you can say, okay. This is just showing you a snapshot of what we will see. Now we can go out of this by right click. Then you see the node there was disappearing, the one that was used on a distance. And I can also, of course, generate a movie. I can follow a node. If this was moving around, I can just select a node that would be the center of the screen. I can go in and I can select coordinates and elements. I can go in and do blanking, of course, in different ways. I can take like a rectangular part window here, and I can remove the elements. Again, you saw I just clicked on right mouse button to get out of that menu. And I can decide if I want to include in the blanking, the final element and discrete particles, etc. I can clear and exit. Contour plot, I can do effective stress, for example. I can say I want to have it for all visible and global and current. This was the effective stress. I can go in and I can do effective plastic strain. I can go back and click these off here so I don't have the mesh lines. Because this is a blast test, I can actually do blast impulse intensity. The intensity is then plotted here. It's very convenient to look at the blast impulse to see how smooth it is. In view, I can reflect this. You can see there's symmetry here. I can actually change that, so I can flip the part around here. I can show the face normals. Tools, I have different tools here depending on what kind of simulation it was. This one does not have fragmentation, which I could have flagged with our node splitting algorithm. Then I would have, and then I would put into output the fragments. I could show more of the fragments, and we will show that in another tutorial. I have formed my limit diagram that we use in metal forming, especially in sheet metal forming. And then I have restart. I can manipulate the restart as well. Here in the object tree, I also have the option of going in and changing, right click on, for example, this color. It comes down, I can change the color. If I want to have a different color, I have different palettes here. So I can go and change that. I can arrange these. Now there's only one part here. Plus we can't see the color when we have the contour plot on. Here we go. And then we can get that away again by right clicking it. So it's a very fast post-processing tool, and it has all the options that you need to make a judgment of your results. This concludes our tutorial on the post mode in the Impetus AFE Solver GUI, and we hope that you had enjoyed watching. If you have any questions, please contact us via support@CertaSIM.com. Have a great day.